So now let us start with the dispersion forces, the first one, right? Now in any atom, okay, in an atom or a non-polar molecule. What's a non-polar molecule? I'll just explain, don't worry. So let us first of all see an atom. So atom has got a positive charge in the center, which we call the nucleus, and it is surrounded by a negative cloud like that. Now that you have studied the orbitals, you know that they are not like that and they are different shapes. But somehow what happens, the center of this cloud falls at the same point where the center of this negative cloud, that is the negative charge, falls at the same point where you have the positive charge. Do we get that? So it is something like positive, and over and above this a negative, and a negative also here, there only at the center. Okay. Now a dipole, there is a thing called a dipole moment. Let us try to understand that first, then it will all make sense why we are going into the nitty-gritties of it. Now there is a thing called dipole moment. What is it? It is if you have two equal and opposite charges. Right now they seem to be point charges, don't worry. Let me first define it. They are separated by a distance of 2a. This is minus q, this is plus q. Then the dipole moment is defined as the charge on any of these into distance. So distance is 2a, so 2a multiplied by q. You understand that? And the unit will become coulomb meter. So the unit is coulomb meter. Okay. The unit is coulomb meter. Okay. Now try to think about an atom. What happens in an atom? Though there are equal and opposite charges, since they lie on one another, the distance between them is 0. So the dipole moment is 0. Understand? So here dipole moment is equal to 0, and we know that it is denoted by mu. Its unit is debye. Okay. So the dipole moment is 0. In a similar manner, there are molecules which are non-polar. So it could be a molecule, but it is such that it is non-polar. That means it has got no dipole moment. We have seen the cases where dipole moment of one of them was there and it cancelled and became 0. Right. So non-polar molecules in non-polar molecules, mu is equal to 0. Correct. Mu is equal to 0. So what do we mean in atoms? Therefore, in atoms, and in non-polar molecules the non-polar molecules are those where the dipole moment is 0, where they do not have a dipole moment. Okay. So, I mean to say the molecules which have molecules with 0 dipole moment, 0 dipole moment are called non-polar molecules. Okay. So in atoms and in non-polar molecules, dipole moment is equal to 0. Yes?
So then non-polar molecules include only the molecules of homogeneous elements.
No, not necessarily. Never.
Because in HCl
If no. Don't make that mistake. There's a molecule here, there's a molecule here, there's a molecule here. The dipole moment of this is this, dipole moment of this is this. So it goes to 0. The net dipole moment is 0. It's a vectorial addition, no? Vectors add, that's all.
Then there are any divalent molecules?
The divalent will not be.
No.
Trivalent will be.
Only the homogeneous.
Divalent molecule. Diatomic. You mean to say diatomic?
Diatomic.
Don't confuse. Okay, diatomic. There'll be no diatomic molecule which will be. No, but just a sec. There can be, no.
Then they would be the homogeneous.
They have to be homogeneous. There will be no heterogeneous molecule, but you know what happens? The electronegativity comes into play. Okay, so if they are almost the same electronegativity, the same kind of thing happens. Okay, so it has got absolutely negligible kind of dipole moment. We call them non-polar. So there could be diatomic molecules with almost the same electronegativity, such that they are non-polar. It's quite possible. Okay. Now, so we understand this, what dipole moment is. So let us try to understand one thing. If I have an atom here and an atom here, what happens? They normally have no interaction between them. They'll have no interaction between them. Why? Because you will be studying later also that since the positive and the negative are at the same point, they attract the positive, the amount by which this positive repels this positive is the same as the amount by which this negative attracts this positive. Okay, so the repulsion force by the positive and attraction force by the negative is 0. They sum up to 0. Similarly, the negative here, okay, so the positive here attracts the negative because there is a center of negative here as well. Correct, it is not visible but it is there. As there is a negative, so there is a negative. So this positive attracts this negative repels this negative, net is 0. Okay, yes, you were asking something.
The diagrams that you have drawn there, the big one and the small one, are those both the same?
They are the same in the sense that here I have just drawn the diagram. This is the charge equivalent diagram of this. Okay. There I am trying to say that the positive and the negative, they are at the same point, and I am not bothered about the space in which the electron is rotating anymore. We get the point. So here the interaction is 0. Okay. So what do I mean to say? Between two atoms, the net force of attraction or repulsion is 0. Say this is A and this is B. Now let us say due to something, due to some factor, let us say this electron cloud gets distorted. Okay. So if the electron cloud of A gets distorted due to some reason, then what happens? Let us say due to some reason, then it can happen in two ways. It can happen thus. So let us say it so happens that there is a positive here and suddenly negative kind of gets stretched like this. When you understand the electric field in class 12th, you will understand this more. So there could be an external electric field. In what direction? So it is in such a direction that it pulls this thing to the left. So a field like this is actually capable of producing. This is an electric field. If this is suddenly subjected to an external field, suddenly transient, okay, then suddenly it will become like that. Now you see what happens. So the positive and negative centers, which were earlier coincident, they get separated. Okay. Now what is the impact on this? So if this is negative, what will it do? It will try to throw the negative away, no? And it will try to pull the positive towards its own side. Why? Because this standing here will have more influence on whatever is happening here than this. Why? Because it is a bit farther away. And why is that? Because Coulomb's law is also like Newton's law of gravitation, where F is equal to K multiplied by Q1 Q2 upon R square. So it is again an inverse square law. So what happens? This standing here makes what? This atom was something like this. Okay, so this atom was something like this. Suddenly what it does? This has more impact on the negative, so it'll push the negative away. Why? Because here the likes repel. The likes repel. So it'll push it like that. So this gets pushed and this gets pulled to this side. So what happens ultimately? Ultimately what happens? This comes something like this, and the negative gets thrown like that away, and instead of this we have the blue one.
Both are positive.
No, this is negative. This is negative. The negative center shifts like that. Okay? Okay? Now what happens due to that? So there is a net negative towards you, so there is a force of attraction between them. There is a net force of attraction between them. You have not done the You have not done the dipoles. Otherwise, I would have shown you. It's pretty simple. That the field due to this, but don't get confused, please. So the field due to a point charge. Okay, field due to a point charge Q is E equal to KQ upon R square. Field due to a dipole is given by E equal to K into, it now starts depending on the dipole moment. So mu, however in physics we call it P. Okay, in physics the same thing is termed as P and not as mu. Kp upon this becomes R cube. It is derivable. In fact, we derived this in class 12th. Okay, and it is asked as a derivation in the board exams. So there is no enigma about it. Had you been a bit kind of into the class 12th, or maybe if you go across the class 12th video, you'll be able to get what I am trying to say.
This is E axial or equatorial?
Huh?
This is E axial or equatorial?
This is E axial. Yeah, this.
So would it be 2K U
This is actually 2KQ. This is 2KQ
upon R square?
upon R cube. No, upon R cube. It becomes R cube. There it becomes minus KQ, half of this, okay, and half of this. So it becomes 2K. What I'm trying to say is that this thing in a dipole, this starts becoming, this goes up by a factor of 1. So instead of R square, it becomes R cube. If it was a quadrupole, then it becomes R to the power 4. It can be shown. It is quite derivable. Okay. Understand? So what happens here? So due to this, so we have been just a sec. We are discussing the dispersion forces or London forces. Don't lose sight of that. This is the dispersion force or the London force. Okay. This is the dispersion or the London force. So you understand, there will be an interaction. Also, if it got distorted like this, so instead of this, it somehow became this. And this will happen when you encounter an electric field like that. Okay, that also you will study. So this becomes negative. Okay, this becomes negative, and due to this, what will happen? This positive gets pushed away, the negative gets attracted. So it becomes a positive charge here and a negative charge here, and there'll again be an attraction. There will again be an attraction. Okay. So this is the manner in which it happens, and it is transient. Okay, it is transient.